Hi, before we get into today's topic, quick announcement. Welcome to my new series of videos where I build, hopefully, interesting projects involving electronics. In my previous video, I explained why I switched my major from computer science to computer engineering, and one reason for this was because I found interest in hardware. I'd recommend you watch it. But anyway, someone proposed the idea that I should make videos where I make projects that are mixed with software and electronics. I thought that'd be pretty cool, so here we are. So Benjamin Calderon? Sorry if I butchered your last name. I got you, my boy. Let's get into it. As you can see by the title of this video, I will be attempting to build a home security alarm system for my room. I think the most beautiful thing about engineering is being able to create amazing and useful inventions. Now, I'm not an inventor. Let's analyze the usefulness of this device. Because it will be in my room, an intruder would first have to successfully break into my house for it to work. Because how else would they get in my room without entering my house first? But what happens when the alarm goes off? Would it prevent something, say, like a burglary? Probably not. At this point, locking my door is more secure than whatever I will be trying to make. But is that going to stop me from wasting my time? Negative. I will be using an Arduino for this project. Thankfully, I had bought an Arduino kit last year filled with some pretty cool toys. You got the Arduino Uno board itself, which doesn't actually say Arduino because this is just a clone of the original. So instead, it says Elegoo Uno R3. It was cheap, aight. But we got LEDs, resistors, motors, and all that good ish. The key component I'll be using for this project though is this little guy right here, an ultrasonic sensor. It's great for all kinds of projects that need distance measurements or projects that involve avoiding obstacles. Here's a basic summary on how it works. It has two doodads, one called the transmitter and one called the receiver. The transmitter emits ultrasonic waves at 40 kHz, and the receiver, well, receives those signals when they bounce back from an obstacle that's 2 to 400 centimeters away from it. So here's the game plan. What I'm trying to do is have it behind my door like this, and when the door is opened, those waves will bounce off this wall and hit the receiver. And when that happens, I'll write a code that sends an electrical signal to one of these output pins on the Arduino, which will power a flashing LED and a piezo buzzer, so it can have that alarm security type of vibe. Let's start building the circuit. The ultrasonic sensor has 4 pins. The VCC pin is where the sensor will receive a power of 5 volts. The trig pin is the input pin that will start the ranging. By supplying the sensor a short 10 microsecond pulse, it will emit an 8-cycle burst of ultrasonic waves at a frequency of 40 kHz and raise its echo, which is the third pin, the echo pin. The echo pin is the output pin, and its pulse will stay high until those waves reaches back to the receiver. How long the echo stays high for will be proportional to the distance of the object. The farther the object is from the sensor, the longer it will take for those waves to come back, meaning the longer the echo pulse will remain high, and vice versa. And we can use that information to calculate distance. Finally, we have the ground pin to close the circuit. Now what you just heard me explain in a mere minute took me hours to comprehend. Now let's write the code that will calculate the distance. I have a ruler here to check how accurate those measurements will be. Alright, let me explain this very quickly because watch time. So here we got a couple variables. The trig pin is connected to pin 12.
I don't care.
And the echo pin is connected to pin 11.
Still don't care.
The travel time variable will store the duration of the signal we get back from the sensor.
I don't care.
We got a float to store the speed of sound, which we'll need to calculate the distance, which will be in centimeters. In our setup, we declared our pin modes and our serial monitor to view our results. Moving to our main code, here we manually supply the sensor a 10 microsecond pulse. Using the pulse end function, we can measure the time period of a high or low pulse. which in our case will be a high pulse of the echo pin, and that is stored in travel time. And here we calculate the distance, which is speed times time. You guys remember this thing from school? Yeah, me neither. It will take twice the distance for the ultrasound to travel to the object and return back to the sensor. We only want to count the distance once, so we'll have to divide it by 2. Now let us check how accurate it is. Here I have a 45 centimeter long ruler, and I'll be using this multimeter as the object for the ultrasound to bounce off of. Let's run it. As you can see, the multimeter is currently placed 15 centimeters away from the sensor, and on the monitor we're getting those exact values. Let's try putting it at a different distance, let's say 10 centimeters. And we're getting 10 centimeters. Let's try 23 centimeters. We're getting 22 and sometimes 23, so it's pretty accurate. Cool, it works. Now let's get into the fun stuff and actually make the alarm by adding an LED and a buzzer. The code that will activate them is pretty straightforward. When the door is open, the distance between the door and the wall will decrease. And we can say if that distance is less than, let's say, 15 centimeters, write a high value to a digital pin. And if it's not, write a low value. And look at that, it's actually working. This is actually kind of fun, and it's pretty loud too. Alright, that's enough. The flashing LED is just blinking on and off every 12 microseconds. But I feel like we need a couple more LEDs and buzzers. Let's add maybe 2 or 3 more. Oh my god, as if one buzzer wasn't already loud enough. Let's see and hear the difference. This is just beautiful. Now let's hook it up to the door. Gosh, this looks so primitive. I didn't realize while building this, but looking at it from here, tell me why it low-key looks like a bomb. Like if I had to give this to someone with no knowledge of electronics, they would probably think it's something dangerous. But anyway, let's see it in action. This actually worked. Who needs ADT when you got this? Like, this is all you need. This is top-notch home security right here. So does it work? Yes. Is it useful? No. It isn't. It really isn't. Why did I even build? If you stayed throughout this whole video, I'm glad to know that I was not the only one who wasted their time. And I would also like to say thank you. If this is a series you'd like me to continue, let me know down in the comment section below. I know this was a very basic project to build, so I tried being creative with it. Keep in mind, these will only get better in time. There's not much I can do with just a kit. When I'm able to get cooler stuff, I'll be able to create much more interesting projects. If for some reason you like this video, please leave a like, and if you're new, hi, my name's Ardens. Consider subscribing. I'll see you in the next one. Take care.